All right, here I'm going to do a few examples today on the video. Then I'll send you out some work to work on, and we'll talk about it next week. Maybe send me an email on Monday or Tuesday that says, well, let's just shoot for Tuesday, all right? Let's give you until Tuesday to work through these things. Send me an email. It says, hey, I'm going to be there Tuesday, 4th period, so I don't forget, okay? Make sense? All right, here we go. So if you have one of these guys, don't write it down yet. I'm still thinking. Okay, here we go. Let's do some factoring. These guys have a 3 in common. You can factor it out. That's hot. These guys are x plus 2, x plus 2. Remember, when you're done, go back and check. We know x times x is x squared. Don't check that. We know 2 times 2 is 4. Don't check that. This times this is 2x plus 2x is 4x. Yay, we did it. Up here, all right, what are the factors? Well, x and x, obviously. Factors of 6 are 2 and 3, or 6 and 1, yes? But remember, they have to add to -1, so they have to be 2 and 3, right? Because they're 1 apart. And this is going to be negative, and that's positive, because that's -3 plus 2 is -x. And then down here, you're going to have x and x, factors of 12. 4 and 3, 6 and 2, 12 and 1. 4 and 3, I'll write it down. 6 and 2, 12 and 1. We know the signs are one of each, because this is -12. And I need the number 4. So which of these pairs, when you add them, or quote unquote add them, subtract them as it were, which of them will get you to 4? Well, obviously 6 and 2. Now, what if you screwed this up, Grim? What if I had -6 and +2? Okay, well, I still get -12. Yes, but that's -6 plus 2 is -4. Bro, I need +4. So I make this -2, +6. Magooch? Now, let's do some cross-canceling. Mr. Groom, I see an x plus 2 here and here. Okay, did you see that? I can cancel them. I can basically reduce the fraction. What about on this diagonal? X plus 2 is in common. That's cool. I can cancel it out. Remember, that's back in the day. You could do 1/5 times 5, 30 seconds or something. Remember that? It's the same exact principle. Now over here on this guy, is there anything top and bottom that's the same? No. Is there anything on this diagonal? No. And so you're left with on top 3x minus 3 over x minus 2, x plus 6. That's it. Now some books, I'm not going to make you, but some books would have you distribute that back out. So that'd be x squared. The bottom, you already know what this one is because it's this one, don't you? So I don't really have to cheat on that one. I can just, boom, there it is. Done. I don't have to. I'm totally fine with this guy. Let's do another. What is happening? Brah. All right, here we go. X squared minus. Don't write this down until I get it written down because otherwise I'll just be stupid and do it wrong and whatever, and that's fine. X squared plus 5x minus 6. Yes, and then times x squared plus 7x plus 6, and then x squared plus x squared minus 1. Okay, so let's go to factoring. When in doubt, factor it out. X and x. Factors of 1 or that. This guy's positive, this one's negative, so they're both negative. Again, always check. That's -x, -x, -2x. Down here, that's x plus, it's x and x. 6 and 1, positive, so that's going to be 6x minus x is 5x. Groom, I tried 3 and 2 first because 3 and 2 add to 5. Bro, you're not wrong, but here's the, well, you are wrong, but think about it. If I did this, okay, the 6 is negative. That means they have to be one of each sign. You with me? If the 6 was positive, you're right. It would be x plus 2 and x plus 3, right? But it's not, because we have to be opposite signs. Always check the outside and the inside pair. Factors of 6 are, of course, 1 and 6, 2 and 3. The signs are both positive. Hey, which of these add to 7? Oh, 6 and 1. Groom, did you do that on purpose? I did. X and X, 1 and 1. Notice that there is no X. There's 0X. Well, how am I going to get 0 from 1 and 1? Well, if one of them is positive and one of them is negative. And so if you check that, it's going to be negative X plus X is 0X. Ching! Look at us go, bud. All right. Can I reduce? Yes. Groom, I canceled this X minus 1 down here and that one. Well, good for you. Doesn't matter. And what are you left with? Well, you're left with X. Oh, dear. No friggin' way. What just happened? 1. The answer is 1. If you think about this, it makes sense. Because had we times this out all the way across the top, I would have got X minus 1 times X minus 1 times X plus 1 times X plus 6 over X plus 6, X minus 1, X minus 1, X plus 1. Everything's the same on the top and bottom. It's very similar to this problem. So 5/16. Well, no, hold on. 5/80. Okay. Groom, is that reducible? Of course, you take a 5 out of it, right? So just don't do it, but you could, yes? Okay. Now over here, we're going to multiply that by, let me think here for a minute. 16, 4 on top, and 40 to 100. I'm doing the math in my head, so don't get weird on me here, bud. So 40. Well, here's what's happened. Okay, let me back train here. So let's see if I do 80 over 2. Don't write this down yet. I'm going to do this. Okay, yeah. This would work. So 2 over 100 times 40 over 2, for instance. Hypothetically, just pay attention to this. Don't get all weird. Actually, let's do 2 over 50. No, let's do 2 over 4. 2 over 4, 40 over 50. There you go. And so if you did that all the way across, you would get 80 over 200, right? But this is 2 times 1, obviously. This is 2 times 2 times 2 times 5. This is 2 times 5 times 5. And this is... Oh, darn it. Darn it. Don't write that down yet. I told you not to write it down, Chase. Don't get mad. Sorry, let's back the train up here. Let's say I did this. It was 4 over 50 times, no, not over 50. 4 over, what goes into 200? 4 over 10, there you go, times 50 over 20. Yeah, it doesn't matter. That would work. They're both fractions. This is 2 times 2. This is 2 times 5 times 5. This is 2 times 5. This is 2 times 2 times 5, which is factoring it out, just like we did over here. True dat? Now, if you put them all the way on top, you get 40 times 50, which is the same as saying 22255 over the bottom, which is 10 times 20, which is 2 times 2 times 2 times 5 times 5, dot, 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 1. Yes, it's the same thing. It's kind of weird. I didn't mean to do that, but it's kind of weird, but it works, okay? So that's neato. If you had this one, x squared minus 12x plus 20. X squared plus 4x minus 12. I feel like I did that one already. X squared minus 36. And x squared minus nice. First thing to think about when you have division of fractions, you always invert and multiply the second fraction. That is the same that you did back in 3rd grade. Nothing changes about that. So times Now it's the exact same problem as before, so I'm not going to beat this to death. It's the exact same thing. You just have to remember to invert the second one. This is x, the factors are 20, 4 and 5, 10 and 2. My signs are both negative, so I need 2 that add up to 12, 10 and 2. Again, always check yourself. Minus 10 minus 2 is minus 12. So this one's going to be x and x. Opposite signs. So I need 2 factors of 12 that are 4 apart. All right, 6 and 2. So that's negative 2 plus 6, positive 4. Up here, x, factors of 36 that add up to 0x. So 6 and 6. Negative 6 plus 6, 0x. X and x, factors of 40, 4 and 10. 8 and 5, 10 and 20, 2 and 20, etc., etc., etc. Okay, but check it out. They need to be both negative. They have to add up to 14. So 10 and 4 work. Negative 4, negative 10, negative 14. Groom. I got you. And we are left with x minus 6 over x minus 4. Okay, that's what I want you practicing on. I will send you some of those. That's what I really want you to focus on. Okay? Perfect.